Xona Microfluidics is pleased to introduce the X4 XonaChip. This X4 chip is what we call a 4-in-1 chip. 4 culture units are provided in one chip, making this chip a huge improvement for automated imaging applications. Further, the X4 chip uses 50% fewer neurons per compartmentalized culture unit, making those hard to isolate and expensive neurons go farther. The new X4 configuration also streamlines the cell loading process using an optimally sized cell loading port. This video protocol provides details on how to prepare and use these X4 chips. Please refer to our main XonaChip protocol for basic information regarding the preparation and use of XonaChips. Place a sterile, multi-compartment X4 chip into a suitable sterile container such as a petri dish. Add 15 microliters of an XC pre-coat solution to the top cell loading port of culture unit A and allow it to flow through the right compartment into the adjoining right well. Repeat the procedure for the 3 remaining compartmentalized culture units. Next, fill the right media wells of Unit A to D with 100 microliters of the XC pre-coat solution and wait 2 minutes to allow the solution to flow through the microgrooves. Now, add 15 microliters of the XC pre-coat solution to the lower cell loading port of Unit A to D and allow it to flow through the main channel into the adjoining left media well. Carefully aspirate the solution from each well. Caution: do not aspirate liquid from the enclosed main channels. Immediately add 15 microliters of PBS to all the top cell loading ports and allow it to flow through the compartment into the adjoining right well. Then add 100 microliters of PBS to the right media wells and wait 2 minutes to allow the liquid to flow through the microgrooves. Next, add 15 microliters of PBS to all the lower cell loading ports. Then add 100 microliters of PBS to all the left media wells. After 5 minutes, again aspirate the PBS and repeat the wash steps a second time. Following the second wash, aspirate the PBS from the wells as before by angling the pipette tip away from the channel opening. Then add 15 microliters of Zona PDL solution to all the top cell loading ports, and then fill all the right media wells with 100 microliters of Zona PDL solution. Wait 2 minutes and then add 15 microliters of Zona PDL solution to all the lower cell loading ports, and then fill all the left media wells with 100 microliters of Zona PDL solution. Close the Petri dish to prevent evaporation, and place the chip in an incubator at 37 degrees C for 1 hour. After incubation, rinse the chip twice with PBS as previously described. Next, aspirate the PBS from all the wells and immediately add 15 microliters of cell culture media to all the top cell loading ports. After 1 minute, add media to all the right wells. Wait 2 minutes to allow media to flow through the microgrooves and then repeat the filling process to the lower cell loading port and left media wells. Prepare a cell suspension of dissociated rat hippocampal neurons according to established protocols. Remove the majority of media in each well of the chip, but leave the channels filled. Next, immediately load 5 microliters of the cell suspension into the upper cell loading port. When loading the cells, avoid contact with side walls of loading port. After loading the cells, transfer the chip to a microscope stage and make sure that the neurons are in the main channel. Wait 5 minutes for cells to attach and add approximately 15 microliters of neuronal culture media to all the cell loading ports. Then add 100 microliters of media to all the larger 6 millimeter wells. Cover the Petri dish and place the chip into a 5% CO2 37 degree C incubator.